welcome back for today's topic. That is, we will discuss about free fall. We are going to discuss about free fall today. So, what is free fall? Before understanding that, let us consider an object. An object at certain height, say this height from the ground, h, okay, at a certain height h from the ground. And if you compare the radius of earth and the height at which the object is placed, that height is negligible, very small, so we can neglect that. Suppose this object is made to fall. If you neglect the air resistance, that fall of the object is called free fall. Okay, so let us consider the free fall of this object now. The free fall of the object now. So what we'll do is we will just consider the three equations of motion. So far we already derived those three equations of motion. So which are the three equations of motion? They are, V equal to V naught plus AT. That is the first equation. And x equal to V naught t plus half AT square is the second equation. And V square is equal to V naught square plus 2AX is the third equation of motion. So considering this particular situation and applying the conditions, applying the terms here in these three equations, what I will get, let us understand it. So here, when the object is falling down, you should know that the acceleration of the object is due to the acceleration of the earth, that is acceleration due to gravity of the earth. Okay, acceleration due to gravity acted upon the object by the earth. So that you know that here acceleration value will be equal to acceleration due to gravity. But you should know that there is a sign convention. Always we'll use some sign conventions while solving these kind of problems. So that you should remember. So always the sign convention is, we'll take the upward direction. Whenever the object is moving in upward direction, that will take it as positive. And whenever the object is moving downward, all the things which we are considering downwards, those things will consider as negative. Okay. So here the object is coming down now, freely falling under the gravity. So this acceleration that of this object that we consider will be having as according to our consideration, these two considerations, this will be equal to minus 9.8 meter per second square. This will be the acceleration of this freely falling object. So here the first equation, this one will become V equal to V naught. V naught is nothing but initial velocity. V naught is the initial velocity that we know. V naught, that is initial velocity. So this initial velocity is when the object is at rest, that is the initial velocity, before it just starts falling down, that is what you call as initial velocity. That is equal to 0 actually. V naught is equal to 0. So this term, first part of on the right hand side, will become equal to 0, and A, as you know, that is minus 9.8 meter per second square into T. So this is what is V is here. So V, that is final velocity. V is nothing but final velocity. V is final velocity. That becomes equal to, I'll write it again. V equal to minus 9.8 into T. Correct? You understand, isn't it? Yeah. Okay. So this one, the second one, that is the x equal to v naught t plus half at square, where x is, the displacement, isn't it? Displacement. X, displacement, yes. X is displacement. So this displacement here, as it is falling down in along y-axis, we will consider x as y, that is in y direction, and this v naught is already, this is equal to 0. V naught t will be equal to 0. So what is remaining is half at square. So a is a negative value, so that is minus 9.8 divided by 2. This half, it's a 2 I wrote like that, and into t square again. So that is nothing but y is equal to minus 4.9. 9.8 divided by 2 is 4.9 t square. This is what you call as the distance y. So that is the case of displacement, and now we are, I termed it as distance also. Distance, displacement, this time I can call it as distance also. Okay, right, because it is falling straightly, both are equal. And here, the last equation, v, the v square, is the square of the final velocity. This will be equal to v square equal to v naught square is 0, eliminated that, so that is equal to 2ax. So 2 times, that is 2 times minus 9.8 into x. So what is x? X is the displacement that we have considered, y. So that is equal to v square will be equal to 2 times minus 9.8, that is 19.6 into y. V square equal to minus 19.6 into y. So these are the values we are getting here. So what you have to understand here is the sign conventions that we have used, and what is free fall. These two things you have to understand here, and while knowing these three equations, you can directly apply the values, and you'll get the corresponding whatever is asked in different questions. You can understand it, you can get it. Okay, so that's it for free fall. Thank you.